Like facing me.
We're so excited that there's so many people that came to see Ben talk today. We're really glad to see you. Thank you. I just want to do an introduction. Ben Brabson is an emeritus professor of physics at Indiana University in Bloomington, and he's presently focusing his research on climate research and environmental physics. Dr. Brabson received a BA in physics from Carleton College in Northfield, Minnesota, and a PhD from Massachusetts Institute of Technology in Cambridge. His present research focuses on relationships among extreme temperatures, soil moisture, and the northern hemisphere jet stream in the Midwest, the U.S. Midwest. Ben is also involved in the process of communicating the science of climate change to audiences outside of members of the scientific community. My husband David and I have had the great pleasure and good fortune to work with Ben during the past 2 years. Ben has worked to make important and profound connections between the arts and the science of climate change, and has shared his research insights and findings with many audiences, including during public presentations at our past art exhibitions in both Bloomington and Cincinnati. During his presentations, Ben has used images of David's dramatic paintings, some of which are here, and global warming, and even some of my small sculptures, and that use stones and driftwood to open up communication channels to all of us in new and unique ways. As an ardent supporter of Ben Brabson and his lifelong research in physics and science of climate change, I am honored to have the privilege to introduce him to all of you. Thank you so much.
Dina, that went way beyond anything that I deserve or could expect. So thank you very much. Let me, lovely folks, how are you? Are you well? You're looking well. Okay.
Are you well?
Fair to middling, right. But we have a problem, and that is that we have this climate change business which we have to come to grips with. So let's get started talking about some things that we can do. Good. I'm seeing people that I didn't get a chance to say hello to, so Jennifer and Anne-Marie and others. Thank you. So let's think about climate change and think about talking about climate change. And the interesting part of this talk is that the majority of it is going to be led by you, because you're the artists. I'm a physicist, and physicists do some things, and they do them pretty well. They're good at looking at numbers and graphs. And there will be some numbers and graphs because I love numbers and graphs. That's the way I talk about things, and the way I think about things. I think in terms of rising graphs or whatever, falling graphs. You, on the other hand, don't always think in those terms. And so the question is, how do we communicate with each other to be really in depth? Are we really talking to each other in a meaningful way? Is it just a matter of looking at two sides of the same coin, as we were just discussing, where you have the science of climate change, and then you have the consequences of climate change, which oftentimes have a lot to do with how it is that you talk about climate change. So let's start with a very simple beginning, which looks like this. The beginning is going to be one, well, let me first say a couple of words about Dina and David, because they're wonderful human beings, and I've been working with them for the last couple of years, as they mentioned. Dina has, in addition to doing sculpture and artwork, has done many other things. I read to you quickly, she's a multimedia visual artist who has taught courses in sculpture and performing arts, contemporary art issues, and it goes on. She's written a book called Why Art Matters, Artists and Peace Building. Interesting connection. David, on the other hand, has done, makes the following comment: my artwork comes from my subconscious. For me, that keeps it true. That's an interesting thought. So the way you keep from being persuaded by others is to let it bubble forth from your very subconscious. That's really cool. I could go on and say lots of things about Dina and David, but there are many, many lovely things to say, and let's move on. Okay, so today, very simple, very straightforward. Some science, those graphs, some consequences, well, two consequences in particular. I'm going to talk about fire and ice and food, the two consequences, and then we're going to delve deeply into the role of art, and that's where it centers on you, okay? So that's what I'm going to do. Starting then with the conclusion. Always good to start at the end. My conclusion, I read it to you, that we are obliged to move away from our own non-sustainable and climate-damaging fossil fuel use as quickly as possible, and that visual art will help us figure out how to do that. That's the way I feel about it today. That other picture is just a picture of fire burning in California, and you and I don't need to emphasize that at the moment because it's happening and happening routinely and regularly. Here's a picture taken in Pakistan, and those people are not dead. They look dead. They're lying on the sidewalk. The reason they're lying on the sidewalk is because it is hot as hell, okay? It is really hot. It turns out that on that April day, this is an April day of 2018, so that's 5 years ago. Since then it's been hotter, but those were record temperatures for that particular April day, and it turns out it was 122 degrees Fahrenheit on that April day in Pakistan, which is unbearable by any measure. So fortunately, this is the coolest place to be, and that is sleeping in the shade on the sidewalk. Okay, so let's talk about global temperatures quickly. These are my graphs, and these are not my graphs. These are graphs that are coming directly out of a number of different organizations. This one turns out to be from NOAA, just showing average total world temperatures, average world temperatures. Each of those bars represents a year, and what you can see is there is evidently a rise. You can't read the numbers at the bottom, so let me just point them out here. This is 1850 up to 2023. So what you can see is in the late 1800s, pretty cool, and then starting about 1900, there was this gentle rise, a middle flat spot in the middle of the century, 20th century, and then this incredible rise going off at the end. And if I exaggerate that a little bit by looking in detail, you'll see that 2016 is really the hottest year. So we're not really at this very moment the hottest year. That turned out to be an El Nino year. It's the case where the Pacific Ocean along the equator turns out to have a layer of hot water, warm water that sloshes across the Pacific Ocean in this case from west to east. And that sloshing takes place and indeed influences the overall temperature of the atmosphere. So one has to be a little careful because looking at a plot of temperatures, you'll notice a huge amount of variation. Notice that indeed back here in 1998, there was a really hot spot, and many of the climate deniers stopping here said, oh, you can see that the climate is not warming. And they kept saying that for many years. And the difficulty, of course, is that there are variations that take place, and they do have a lot to do with El Nino and La Nina and small events that take place. So how do you interpret these graphs when there are lots of ups and downs? And the ups and downs are in fact built into the system. We have an enormous amount of variability, as it's called. The variability comes from many things, including things like El Nino. Well, this is a graph that goes back 1,000 years. This is 1,000 years ago, and this is 2000. This is today, more or less. 2020 is that red line. And what you notice is something funny is going on. It is certainly true that there are variabilities and variations. And all these wiggly lines are made from different proxies. There are different ways to measure temperature, not surprising. You can have a thermometer, but we haven't had thermometers for 1,000 years. We've had thermometers for about 400, 350 years, but not 400 years. So the question is, where did all these other wiggly lines come from? Well, there are lots of ways of measuring temperature, not the least of which is to look at ice core data. You can look at the way, if you go into a cave, you can actually look at the way stalactites and stalagmites form. All those things actually have a record of temperature. Even the shell of a crustacean in the ocean does record temperature, interesting, year by year. So there are lots of different ways to measure temperature. Here are a whole bunch of them, and what you can see is that yes, there was back here in 1200 a medieval warm period, and there was something we call the mini ice age, which is this area here. And oftentimes, again, if you're talking to skeptics of climate, they will say, well, the climate always changes. And that is true. The climate does always change, interestingly. On the other hand, here is 2022. So something different is going on. This is not the usual situation where you get ups and downs in climate. There's a lovely book published by the Enterprise Institute, which we will not talk about very much, but they happen to show a beautiful plot showing this plot. They simply left off the last 100 years. It's very nice. Interesting thing. Well, if you leave off the last 100 years, then indeed there is variability. Here's one more plot, and then I'll leave you. We'll leave plots. But this plot is actually a more useful plot for climate scientists. It's one that came out last year, measuring very carefully the temperature of the ocean. Okay, why ocean? Well, about 70% of the world is covered by ocean. Okay, the ocean is also basically black in terms of absorbing solar energy, and so it's actually a much better measure of what is really going on in increased temperature on the Earth. And if you look at the ocean temperatures, they are much more stable. Not surprising, because of course the ocean, as I said, is black and big. Look at the ocean rise in temperature back here, and this is now talking about 1960 to 1990, say. This slope turns out to be the rise in ocean temperature in the last part of the 20th century, which you and I can remember, most of us. There may be a few youngsters in here who don't remember the last part of the 20th century, but the rest of us do. Ocean temperature rising gradually and relentlessly, perhaps. And then notice this slope here. This turns out to be about 8 times faster than this one. Well, that's pretty scary, guys. That's pretty scary. That says the ocean temperature, which is a very good measure of climate change, is actually the thing that we should really pay attention to. Okay, so there are some graphs, and those are some things to concern ourselves with. These are just a group of ocean scientists. I read to you their conclusion from last year, an IPCC report they came out with, and they said their conclusion was that ocean warming, acidification, and deoxygenation, I can hardly say that word, ice sheets and glacier mass loss and permafrost degradation are expected to be irreversible on timescales relevant to human societies and ecosystems. Now wait a minute, that's what you call scientific jargon, but let's go back and just look carefully at what those last pieces said. It said all sorts of things are changing, including glacial mass loss, permafrost degradation, and so forth, and are expected to be, and I'll read this again, irreversible, bad news, okay, irreversible on timescales relevant to human societies and ecosystems. All right, what are our timescales that we're talking about? We're talking about lifetimes of human beings here, now. So 100 years, are you expecting to live 100 years? Well, perhaps, but most of us won't live 100 years. But the point is, our ecosystems and human societies' timescales are perhaps of the order of a few hundred years if you stretch it a bit. And Jim Calley will help us stretch it. But there you go. It turns out that on that timescale, we're in trouble, okay? We're not seeing the dangers that arise. Well, all right, so now we enter gently into art in an interesting way. Suppose you were just to take each of the numbers that I've been presenting to you and you just change them into colors of thread. Interesting thought. And you simply presented those as a way of looking at increases in temperature. Well, it turns out that Tali Weinberg has done that in many different ways. Do any of you know Tali? I don't know her, but I was delighted to find her use of this technique of simply taking numbers and converting them into colors. Interesting thought. So here's an attempt to look at ocean rise in temperature, and what you see, it goes from really cold to really hot, or atmospheric temperature, again, going from cold to hot. it gives you a different impression of what's going on. Well, Tali is onto something, because here, it turns out, is the IPCC report that I came across this morning. It turns out it came out just 2 days ago, so it's not surprising that all of us haven't read it, but it is a book of 800 pages, so we have to get cracking if we're going to read it. But the point is that if you look at what is called the executive summary of the IPCC report put out 2 days ago, which is indeed coming from the synthesis report, which is the final volume of that report, instead of using graphs, the most important single feature of the first diagram in their discussion of the policymaker's summary is this graph. Interesting that they choose a different strategy. They're not giving you a graph. They're giving you a color distribution, which is interesting, because now you can go back and see, 1900, I give you the numbers, 1900, 1940, 1980, and they're using color effectively to show the difference between really cold, blue is down here at 0, that is average temperature back in 1900. Comparing to 1900 then, things get warmer. This is 4 degrees warmer, and we're going to talk a little bit about how warm is warm. Typically, the number 2 degrees C is the one that people use and bandy about, right? You've heard the number 2 degrees. We have to stay below 2 degrees C. Well, 2 degrees C, of course, is already about 4 degrees Fahrenheit, which is already pretty high, given that the difference between our last ice age and present was only about 4 degrees C, maybe 5 degrees C, could be higher. But to go from ice age to present, that's pretty dramatic. And now we're talking about going from present to 4 degrees in the future? That's bizarre, right? The idea is just scary. Okay. Anyway, looking here, you can see in color, they're using a very interesting strategy. And so if you're born in 1950, so I was born back here in 1938, but if you're born in 1950, you can see what's going to happen to you as you get older and older, and the redder you get, that means the hotter it's going to be. And of course, if you're born in 1980, nobody in here born, no 1980s. Born in 1980, you're going to be really hot by the time you get to be 70, and if you're born just in 2020, you're indeed in purple trouble, so to speak. So it's an interesting way of using a strategy which is a little like an interesting way of using art. Okay, enough said about IPCC. They seem to be doing some clever things. Giving full credit to the research that has been done, this is one of my favorite little tidbits of information, a very important one, and that turns out that Eunice Newton Foote, who was a pioneer in climate science in 1856, published a paper, and these are just numbers coming from her paper, saying that actually, you know what, it turns out that CO2 does create warming. And she was the first to actually publish those results, even before Tyndall and others came along and said it's really, not only does it happen, but it's actually due to the infrared radiation that is trapped by CO2. The interesting thing here is that she simply took carbonic acid, which is just basically something that produces CO2, put it in a bottle, and simply shone light on 2 bottles, one which had carbon dioxide in it, the other which was just air, and she noticed there was a huge difference in temperature in the sunlight. Absorption in its simplest form. Well, just for fun, we did that experiment again at the open house in the physics department just this last fall, and you can see that all these people are looking. They're looking at the wrong experiment. The experiment's over here, but we set it up with I had to show the picture. Set it up with bottles, and you shine light on the bottles, and you have one that has CO2, one that has air, and then one that has methane, and you can do all sorts of clever experiments, and it works. You find out, not surprisingly, that CO2 really is a great absorber. And you also find out that methane is a huge absorber of CO2, of infrared radiation. So there we are, just enjoying doing Foote's original experiment. Great fun. One other graph, and that is this one that shows what is going on with regard to CO2, which is one of the greenhouse gases. It is the major greenhouse gas, I must admit. It's probably responsible for about 70% of the heating. And over the last 60 years, from 1960 to 2020, it's rising and seems to be essentially unwavering in its trajectory. If I look just at the last 5 years, then I see this pattern, this seasonal pattern where it rises and falls. This turns out to be February. This turns out to be January. This one turns out to be December. And what you notice is that all winter long, the CO2 is rising very rapidly. And evidently during the last summer, it kept falling. And I have to ask you to be sure you're understanding this. Why is it that in the summer, CO2 actually goes down? Trees, right, thank you, trees. Good thing, trees. Love trees, all right. So, indeed. But what about the trees in the southern hemisphere? Well, they're there, but there are not as many of them. The northern hemisphere does dominate, and so the trees actually do absorb CO2 all summer long and reduce the CO2 in the atmosphere. All winter long, unfortunately, we don't get that effect, and so CO2 rises very rapidly. Okay, so what's happening, interestingly, is that that number right now is 420 parts per million, and on previous occasions giving this talk, it was 380 parts per million, and 390, and 400, and so it keeps me on track. If I simply remember every time I do that plot, I have to raise that number and do a new plot. Okay, so that's what was going on at the end of February. Fine, and then if I look on a 1,000-year time scale just to get an overall sense of what's going on, here's 1800, and sure enough, in 1800 there was a huge increase in CO2, almost certainly due to the Industrial Revolution, which started burning coal and so forth. So huge increase here. That red line is just the one we looked at a moment ago, and here we are at 420 parts per million. So something really dramatic, lovely folks, is going on. It is not just easy stuff. Okay, enough said. Science, okay. Lots going on. We can talk about the details, and the IPCC report of 2 days ago does just that. It gives you all the details you need about what particular temperatures are rising and so on. Okay, so there are consequences of that. I will talk about only two: fire, ice, and food. And at this point, we begin to enter into a world where art may turn out to be at least as effective as other mechanisms for talking to people about what is happening. Conversation is fine, words are fine, but in my view, sometimes art in the form of photography here or in the form of David's magnificent painting. David, what is the name of this one? I've forgotten.
Paradise is Burning.
Thank you. Absolutely terrifying at any level, and I am. It's wonderful to be in this environment where I can then see full face what you can see when you turn around. But the point is that it is a remarkable way of communicating not just the fact of fire, but the implications underneath it, the tensions that arise, the sense of anguish that I feel in the painting, which is not in the, I mean, all right, there is anguish in the right-hand photograph, but I feel something else when I look at the painting on the left. There are a couple of other details with regard to sea ice. This is just showing ice in August of 2020. This is looking at the North Pole. It's really hard. There's Alaska over here and Greenland over there. This is the north part of Norway over there. And of course, as the sea ice melts, there will, in the summer, be, no doubt, a free path going from Norway straight across to Alaska, right through this big chunk right now, which is just ice. It's not land. There's no land there. It's just, it used to be about 6 feet of ice. Now it's only about 3 feet of ice. So it is true that we're losing ice not only in area, but almost as importantly, or even more importantly, we're losing it in volume. That is, going from 6 feet to 3 feet is huge. And the fact that that 6 feet has gone to 3 feet, and that we are now projecting that that will be ice-free by 2050 is really getting close to scary. All right, so there it is. That the red line, of course, is the line, the sea ice extent back in the average of, sorry.
Did you say 2050 or 2015?
2050, yeah, we have it, right. No, thank you, 2050, 50, right. This is the average line for 1981 to 2010, so that's only That's 30 years period, but it's only 10 years ago that that ended, and here was the average. And you can see that it's changing. The one piece of that which you and I know about is that that also is something which is called a tipping point, because it's one of those situations where as you reduce the coverage in ice, you also reduce the reflectivity of that ice. The reflectivity of the ice is really important. It keeps the Earth cool by bouncing solar energy away from the Earth. As you lose that reflectivity, as this becomes darker and darker, ocean and ocean, more and more ocean-like, you lose that capability then of reflecting light away from the northern hemisphere, and that then means that an increase in temperature produces an additional increase in temperature. That's what positive feedback is. Negative feedback also exists. It is true that you could have an increase in temperature which will produce a decrease in temperature. Example would be that if I have more warming, I may get more cloud. Well, more cloud would then reflect light. And so there are both positive and negative feedbacks. And so it's not, I'm simply not going to stand here and say, positive feedback, terrible thing. It is a terrible thing because it can be exponential, but it's also true that you have to be really careful about how you do those positive and negative feedbacks. This one turns out to be positive and scary. If you do a climate model, which can include many of these effects, then you can get a better estimate of how dangerous it is. It turns out that the danger is real. Okay, so I can't resist looking here. You can turn around and look at the real product. This is a poor representation of it. I put it next to a picture which comes from just a few years ago, about 3 years ago, where there is and continues to be in the summer a huge amount of melting that takes place on Greenland itself. The rate of loss of ice in Greenland is astonishing, and David's painting is a tribute to that, which is just absolutely miraculous and moving for me. Thank you, David. This is, I'm going to skip this, but James Baylog needs to be put into your psyche at some point. He does something which is time-lapse photography, taking pictures of glaciers and then showing over a period of 10 years, 5 years, even 3 years, what happens to a glacier. And if you watch a glacier, it will simply retract in front of your eyes. It's just scary stuff again, but suddenly the glacier, which is big, is simply retreating up the valleys and so forth, and is disappearing. And so that is another strategy. I don't know whether to call it art. I guess I would call it a mix of science and art together, but it's a very effective way to see changes that are hard to see on a day-by-day basis. Okay, James Baylog, wonderful guy. Okay, there are other things that are happening which in some ways are are worth considering. If you're a gardener, you worry about plant hardiness zones, and it turns out that if you look here in 1990, there's Indiana, and Indiana was dark green in 1990 with a few exceptions at the southern tip. The dark green was actually a hardiness zone of 5. And if I go then 15 years, if I go 25 years into the future, and look at 2015, I will find that here is Indiana again, and Indiana now has changed colors. Well, that's very nice that we've changed colors, but so what does that mean? Well, it means, lovely gardeners, that suddenly instead of being in zone 5, we have moved up to zone 6. Interesting thought. How long to get to zone 7? It turns out not to be very difficult to calculate when we will be in zone 7. Another way of thinking about it is that Indiana is basically moving south. Nice thought, if you like cold weather or don't like cold weather, but it's an interesting detail that things are changing here in Indiana. Okay. The difficulty is that as it gets warmer, you also lose the productivity of our 2 major crops, which turn out to be corn and soybeans. Now, I don't raise corn or soybeans, but they are really important in Indiana. And what you notice is that as temperature rises, the productivity of corn and the productivity of soybeans both decrease with temperature. That's an easy thing to measure, and it is a little scary because it means that we, as a producer of food for the world, we certainly produce much more than we eat here in Indiana, is suddenly becoming less. We are less able to support the world with food, and that is happening worldwide, not just in Indiana. It's nice to look at Indiana or Midwest, but it turns out that that's something which is critical worldwide. So if you lose your, well, all right, so you could, our dilemma. On one hand, we have sufficient carbon-based fossil fuels, think coal, to run our society at or above present levels for at least 150 years. That's certainly true of Indiana. Indiana has coal. It has enough coal, it turns out, to run at present levels for about 400 years. We actually have a huge amount of coal in the ground in Indiana. And at our present rate of usage, which is about 50 million tons a year, we have enough coal indeed to last for the next 400 years. Okay, but to do so will drive up the Earth's surface temperature to levels sufficiently great to reduce its carrying capacity. You simply can't feed those 8 million people, soon to be 10 million, sorry, 8 billion people, going to 10 billion people, 10 billion people, if you lose capacity to feed them. All right, so food, critical. All right, ice, food, two things we talked about. Enough. Okay, now we do art. Let's dig into art. Okay, up until now, it's been my show, now it's your show. Okay, so we're going to talk then about the role of art in communication of science. And this is the part where it's, I'm just sitting here going madly ahead and backward and forward. I'll just get back to the beginning. There we go, okay. Well, this is a photograph. This is not a painting, but it could be a painting. Greta Thunberg is sitting here early in her career, very early in her career. She was a middle school kid who was on strike, I think a sixth grader on strike in August of 2018, and that says basically school strike for climate. And she was pretty much by herself. Her buddies were not crowding around her. This was in the rain in Sweden, and it is a magnificent portrait of I don't know, anguish is the wrong word. Determination, I guess, is the word. I mean, here she is as a young kid sitting there in the rain with no intention of leaving, and leaving school to do it. And then she went on to do other things, including talking to the UN and pointing out some of the things that are really important. And a quote from her, of course, which you've heard many times is, "I don't want you to be hopeful, I want you to panic." Okay? I want you to panic. Okay. This is a picture from November 2021, which caught my eye, and I'm sure maybe yours as well. This is on the Poland-Belarus border. It's not on the Poland-Ukrainian border, but they're very close together. Turns out these folks are not fleeing war, which they could well be. It turns out they are indeed trapped on one side of the Belarus border. Belarus refused to let them in so that they could get on to Latvia, Lithuania, and so forth. And here they are as climate migrants, as they're really coming from major countries where desert, where drought has forced people out of certain regions, largely in Africa, but elsewhere as well, where it simply is untenable, where you simply cannot make a living. So that brings to mind, again, it's a photograph, it's not a painting, but it has a certain empathy for me, or lack thereof. Going back to David's magnificent painting, which is right here, Village Flood. All right, Village Flood reminds me then of pictures from Bangladesh, where these are kids who were flooded out of their homes. The Bangladeshi folks experience flooding largely because of ocean level rise. It turns out a good portion of Bangladesh, as you know, is at sea level or below sea level as time goes on. So there are all those small countries in the Pacific which are literally going underwater. Bangladesh is in some ways equally important or more important because it's a huge population which is now being subsumed by the rise in sea level. So there are lots of ways. They had to have school on a boat because the boat could then rise with the water. Again, photographs bring to mind disaster coming again from changes in climate that are taking place. One can argue that this was a storm, and you cannot attribute a single storm to climate change. That is not fair, but you can indeed show the increase in probability of storms relative to climate change. Again, the tar sands in Alberta, disastrous picture, again, a photograph. This one I want to spend just a moment on. This turns out to be one which scares me considerably. That is, this is a picture taken of clay being dried in the sun in a portion of Brazil. And ordinarily that wouldn't be a scary picture or one that I would be concerned about. The difficulty is that the folks who are doing this are doing it in a way which is very strange. They are taking the topsoil off of the fields in order to turn it into clay so that they can make clay roof tile. The difficulty with that is that this small region in Brazil, which is right here for the larger scale, is doing it in such a way that they're more or less eating their future. That is, if you remove topsoil, you also remove your life sustenance. It takes 1,000 years to deposit an inch of topsoil. These folks are removing topsoil 6 inches at a time with nothing underneath. That is a sure way to be in a disastrous circumstance. I mean, that's not even feedback, that's just poverty exercising a really difficult situation. Okay, we're making progress. At the same time, this is part of the same picture, it turns out they then chop down all the firewood in order to cure the tile. So they build fires using the firewood, which is the only remaining firewood in this area. They won't have any more firewood because they just took the topsoil away. So this is a one-shot effort to survive. That is just terrifying, in my view. Okay, looking at David's painting, which is, I don't know, this one may not be here. Ah, okay. Well, this is a picture of a series of streets crossing each other, and you say, oh, that's got to be an exaggeration. That can't be a real photograph, but it is, unfortunately. That turns out, I've forgotten where it is, probably Los Angeles, but it turns out to be a magnificent photograph, and here is David's painting to go with it, and they look the same so far as I can tell. I mean, David's painting is much more fun, but it looks to me as if that series of roads there is just crazy business. So we are doing funny things with our society, and one of which is to build roads in such a way that our natural environment is being changed by us. Okay. Well, here's another picture that I like. This is a picture. Do you know where that is? Can anyone tell where that is by looking at it? It's pretty hard to tell. It could be, I call it, David calls it suburban carcinoma, but that's not the painting. That's a real picture.
Are those houses?
Any thought? Sorry?
Are they houses? I can't tell from the Are they houses?
Yeah, that's a house right there. That's a house, right? And it goes on and on and on for miles and miles, and there are roads here. You can see roads and streets and so forth. It's a city. It's Mexico City. I have not been to Mexico City except on the plane, but it is a remarkable scene of how it is that we as human beings can indeed change the landscape. Not to complain about it, but what is wonderful is that David's painting indeed shows much of the same circumstance going on in something which he calls suburban carcinoma. This is something I slipped in there from Tally Weinberg. This is her, that's a piece of cloth which she has woven, and she calls it Drought from 2013. That's 2015. That's a pretty, well, it looked like drought. It looks very dry and very, very emotional. On the other hand, there are lots of things that can be said that are positive as well as negative that take place in art. And I show a picture from Hubble. This is just a picture showing a tiny, tiny portion of the atmosphere, of the sky. Each of these little fellows here turns out to be a galaxy. They're not stars. There are a couple of stars in here, but very few. The vast majority, that's a star, but that guy turns out, that guy and that guy, those are all galaxies, each of which has perhaps 100 billion stars, like our Milky Way. So that's a magnificent view of where we live and what we are doing. That's just for me because I'm a high-energy physics person who likes quarks and gluons, and those are the two up quarks and the down quark, which turn out to make the proton. So we'll skip that for the moment. Beautiful stuff. We live in a magnificent world, and this is a picture of a sunflower, of course, with this marvelous, I mean, it's just remarkable that, again, a photograph, but one that can show the nature and the nature of nature, how it is that such beautiful things can exist. It reminds me of Fibonacci numbers for those of you who like Fibonacci numbers. Next door, there is indeed a lovely exhibit by Christy Lindberg, and I put it here just to remind you on the way in or out that you can take a look. Christy is a stormwater education specialist here in Bloomington, and I put this here simply to remind us that even that a stormwater education specialist can get involved in the business of understanding how it is that we relate photography, in this case, to climate change. All sorts of things happening in that picture that she can talk about. You can see the green algae growing at the top. All right, Dina Hawes, I'm going to talk a little bit about you. In that case right over there is this marvelous piece, which is, and I quote from Dina, "I think of my artwork as an intimate, immensely intimate, small-scale, evocative, and emotionally powerful thing." And that is a piece of something which is basically limestone with silver. And there are two things going on. One is that the limestone is very old, and the silver also very old, of course, if you go back to the atoms themselves. But the atoms have been reshaped in recent times. So that beautiful silver reminds me of something that means that we have to think in terms of time. What is going on? We have things that are really old and things that are really new. If I look in detail at Dina's beautiful piece of artwork, I will find that it has crinoid stems here and other ones here and there. You can find there are all sorts of little bits and pieces which you found if you go out in the local creeks and so forth around Bloomington. You will find all those little guys. And so that limestone, lovely folks, is made almost entirely of material left over from actual live things, okay? And it is interesting to me that is 300 million years ago. That little guy right there is 300 million years old, and so is that guy probably, or something close to it. It's impressive that something can have a time scale which takes us back so far into our distant past. And yet at the same time, there is something which brings us up to date. So the whole idea of time turns out to be essential in thinking about climate change. So how is it that time and climate change go together? Well, let's just take a look at another piece, which is sitting over here. Dina, you have to remind me of the name. This is called Traces of Life #1, I think. Traces of Life #1 is a beautiful piece of silver embedded again in something which is incredibly old. Let's take a close-up look at that. Here it is. What you can see if you look carefully at the stone is there are all sorts of bits and pieces of evidence of life of 300 million years ago or older. And then there is this magnificent piece of silver in the middle, which she has created. I think the thing that comes to mind when I look at that is that here is something which starts out very small and gets bigger and bigger and bigger. Think population, for example, in the Earth. As our population increases, we have other problems that we've talked about that have to do with climate change. The other detail is that if you go from something which is really big to something which is really small, you can think then about the fact that many of our species are indeed in deep trouble, and that as you look at large numbers of various species of birds, for example, you can imagine at some point that they are indeed going away. So you lose this capacity, you lose this whole business of extinction through extinction of species. So I see, again, something which reminds me definitely of how time evolves in our lives. Here's one other piece that is magnificent, Last of a Species on the right. And I quote again from Dina, "I find that certain pieces of driftwood and certain found creek stones can act as symbols or pointers to potent memories. They offer a sense of timelessness as the long-lived processes that wear them down to form evocative shapes." Here I put it just for fun, a picture of the bristlecone pine, which is more than 5,000 years old. This is not a picture, I assume that piece of driftwood is not a piece of bristlecone pine, but nevertheless, they do bring me it is evocative and a beautiful piece, I must say. Stories, another really important piece of the puzzle. I'm almost done. A couple of more slides here. Stories are really important. This is a story of the frog. The famous frog story is the one where, of course, you put a frog in warm water and then you heat the water up gently and slowly, and the frog really likes the warm water, and so he stays in the warm water because it's so gentle and nice. And this is a picture of a group of many pastors and clergy from different churches who are actually reenacting the whole story of the frog at a climate change event, which was celebrating the fact that we had solar panels on a number of churches in town. So the story is a good story, and it is oftentimes a very good way to remind people of what can happen. Of course, eventually the frog, if he doesn't jump out of the boiling water, will indeed be cooked. Stories, very powerful. Music also can be powerful. I'm going to skip that because we're a little over time, but there's a lovely bit of work that goes on where music can be very positive and powerfully used in the discussion of climate. This is a picture of evidently a very enthusiastic person. Her name is Adani, I guess. I don't know how to pronounce it. Adani, I guess, is singing her heart out as she's singing 4 Degrees, which is one of the songs that she's written about the disasters of climate change as they come along. Humor also, this is my favorite, one of my favorite bumps. That's good old Moses. He parted the Red Sea, but then there's all that damn plastic he had to get rid of at the bottom. So that's a cute way of saying their problems. Finally, this is my final slide. Let me read to you something called Messenger by Mary Oliver. My work is loving the world. Here the sunflowers, there the hummingbird, equal seekers of sweetness. Here the quickening yeast, there the blue plums. Here the clam deep in the speckled sand. Are my boots old? Is my coat torn? Am I no longer young and still half perfect? Let me keep my mind on what matters, which is my work, which is mostly standing still and learning to be astonished. The phoebe, the delphinium, the sheep and the pasture itself, which is mostly rejoicing, since all the ingredients are here, which is gratitude, to be given a mind and a heart, and these body clothes, a mouth with which to give shouts of joy to a moth and the wren, to the sleepy, dung-up clams, telling them all over and over how it is that we live forever. Lovely folks, that is the end of my talk. I summarize here: climate change is underway. Its severity is driven by carbon fuels. Climate change is a threat multiplier. It makes things worse. Extreme temperatures, drought, storm severity, flood, hurricanes, species loss, and human migration are all part of it. Unawareness of climate change leads to business as usual and an unprepared future. Awareness of climate change leads to engagement, personal response, a clear understanding of where we are and where we can be. That's it. Thank you. Thoughts, questions? Yes, Stan.
We don't need to go back, I think, to the slide, but the slide of the universe. And you said, you pointed to a star, and you said that there were 150 billion something or others.
150 billion stars in each of the...
In there. So what I'm asking about is not the 150 billion.
Okay.
Is
I was hoping you would ask about
what's the, just in the time we have left, what would be the positive and the negative side of those 150 billion stars?
You're asking a good question. What possible relevance does it have to climate change? And the answer is absolutely none. What it does is to point out something else in my mind, and that is that if you look at our world, it's a pretty magnificent place. it's a pretty special place we live in, with lots of good things going on as well as lots of bad things going on. This steps back and says, all right, let's take a look at what is the world without our interference, so to speak, without human changes in our details. And what I see is something that is pretty remarkable. Now, it's magnificent is the word. So I guess I'm struggling to insist that we keep our curiosity alive, that we make sure that we are astonished by things. And this, to me, is absolutely astonishing. There are things happening in the world today that have to do with climate change that are astonishing. For example, it turns out that in Egypt, in this last COP, the Conference of the Parties, where they were talking about climate change, one of the things that was actually remarkable is that if everybody actually contributed to their reduction of CO2 that they promised, that our total rise in temperature would no longer be 4 degrees C, which it was, in fact, in 2015, but would now be something as low as 2.7 degrees. That doesn't sound like very much, but it's a heck of a lot better than 4 degrees. So some good things are happening at different levels. The fact that people are installing solar panels here and there, for example, in churches, in homes, has a huge impact on the way things actually work. So it's very easy to be completely depressed by the whole thing and just go off and say, to heck with that. Or it's interesting to notice that lots of things are actually happening. The whole MIT book that I received just this afternoon turns out to be full of all sorts of ways of reducing CO2 in the atmosphere, including extracting CO2 from the atmosphere. So all sorts of people, including the scientific community, others are thinking about how to do it, how to actually get there. So suddenly, instead of huge depression, there is energy. That's good. And it comes, I think, originally from curiosity, but then also from amazement. Remarkable. So that's the essence. This is something which keeps me amazed always at what happens and what human beings can do. Human beings can do terrible things, or they can do wonderful things. Yes.
Talk about the night sky.
Yes.
Because our atmosphere is changing. There are many, many people in this world who have never actually seen what a night sky can be.
I had not thought of that. You're exactly
But
right. That reminds them that it is there, the night sky, but they've...
You have to go to remote places to see it.
Yeah. And when you go to one of the remote places, it is astonishing.
It's just amazing.
It is. It
You
just
can see the Milky Way and the colors.
Yes. And they're just overwhelming, brilliant. It's not. You can't even see the constellations anymore. There's so much up there going on. It is truly remarkable. Thank you. Other thoughts?
Oh, yeah.
Yes.
Hi. Christy Lindbergh, education specialist. Another third. Thank you. And I just wanted to say here locally, we are involved with a number of things that are helping folks adjust to our changing climate.
Christine, yeah.
We at the City of Bloomington Utilities,
Thank you.
including grants for people who are experiencing erosion in their yards. We're even working on a education program for landscapers to help them adjust to it as well with practices that help our soils. And we're going to be soon doing neighborhood visits, going out there and talking with neighborhoods about what people can do and how we can all really work together on this. We also have a storm drain marking program, as well as an adopted drain program, and the list goes on. Anyway, talk with me later if you'd like to learn a little bit more.
Christine, that's brilliant. Thank you. That we have this gully which runs down the back of our yard, so I'm going to come consult with you.
Yes, seriously. We're looking at things bigger.
And you
bigger
don't
picture.
know
Oh, you are.
You don't know that your house is losing 1/32 of an inch every 100 years
You're disappearing, right?
in that gully.
Right, in the gully. Poof. Soon to be wiped away. Yes. Good.
we know the consequences, what's happening now, and how rapidly everything is changing. It tells our story and how we are going to vanish some, but life on this planet will go on, and it has gone. It changed. Many civilizations have changed, species, dinosaurs have changed, all that. Well, life will go on this planet, but we are destroying ourselves in the process of just increasing productivity. We didn't talk about what we could do more. If you could please tell us, like, what would be the policy that we can bring into our current life to make we reduce this climate change. Could you talk about that a little bit more specifically? Thank you.
Sure, you're asking the world's hardest question. Question is what we notice is that given the last 140 years of warning from Eunice Foote all the way to the last 30 years, which have been the IPCC reports, we don't seem to move very quickly, even though the information is there. So it occurs to me that the puzzle is one which I'm not going to be able to solve, but I can suggest a couple of things. One is that there are two pieces to the puzzle, at least. One piece has to be governmental. The second piece certainly has to be industrial, and the third piece has to be human. That is our contribution. And without all three, it doesn't work. So the governmental piece is being resisted to some extent by to a huge extent. Governmental piece is being resisted by folks who want to preserve maximum benefit for themselves personally, and they're not interested in the idea of supporting collaborative work, which is basically governmental work where we work together on some project. If you have something like climate change, which does not pay attention to borders, then everything has to be done at international governmental level. National governmental level, great, but also international level. It has to be something where everyone agrees. And the 2015 COP21, as it was called, where John Kerry did a huge amount of work with other governments, put things together, was a huge step in the right direction because it got us started in doing something together. So item number one, by any measure, duplicate John Kerry. Take him, just clone him, whatever you have to do, just get a bunch of them and get them going. There are a number of John Kerry types out there, and they're working exactly in this direction. So that, I think, is my first and most important single thing I can say. There will be resistance. The resistance will come at many levels and for many years. And ultimately, people will react. The difficulty is reacting too slowly. If we don't pay attention, if you don't care about California because you're the other side of the aisle, then you can let California burn and let it do its thing. So what you have to do is somehow get into this frame of mind that actually what's happening with them will eventually be very much what's happening with you. So it's the business of convincing people that it is not something where you can look and say those guys are going to suffer their own difficulties, I will ignore them. It has to be collaborative. So collaboration takes place then at governmental level, and then the second piece, which is the piece you and I were talking about earlier, is you have to have the muscle. And the muscle has to come from the industrial base that we have in place. You're not going to get there, unfortunately, in my view, with, to exaggerate, of course, with LED light bulbs. That's not going to do it. Solar panels on all houses in Germany, wonderful thing. Germans are doing very well in many regards, but without having that conversion coming from the industry, it seems to me it's going to be difficult. Now, some of that is happening already. It turns out industry is very interested in taking advantage of all those bits and pieces of the industry where they can make a bit of cash. And there are lots of ways to make that happen. And it seems to me that if you don't take into account the fact that industry is a piece of the puzzle that it's always going to be tough to make progress. The third, of course, is the huge impact of human beings, and that is getting this group to talk always about it, keep talking about it, always make sure your legislators understand that. Yes, question?
That last piece that you're talking about in human piece, I think anything can happen when there's enough will to make it happen.
Yes.
And so there has to be a groundswell of people who are pushing that will, who are pushing that issue, that whatever.
Right.
Downstairs is another art exhibit by Artists for Climate Awareness.
Ooh.
And they have a little handout there. And one of the things that I found really useful, and it wasn't successful in my family, but that doesn't mean it wasn't useful, is how to talk to people
Yes.
about climate change.
Yes.
How to diffuse some of the emotional knee-jerk reactions and things like that. Like I said, it didn't really work for me. I have a brother who has a grandson
Yes.
who's gonna be coming of age in 2050, okay?
Yes.
You know, to me, I don't have any kids, to me, he ought to be jumping into this issue with both feet.
Right.
But he's pretty far right, and he's pretty much, you know, that's all tree hugger crap and, stuff like that.
Right.
So I did try to use some of the techniques, but I think we have a history of, well, not really screaming at each other, but slamming the phone down, cutting off the Zoom, and, things like that. So I, like I said, it wasn't too successful in that particular case. But the handouts that they have are really helpful.
Perfect.
They're tried and true, and I think the more we're talking to people, and I don't just mean our relatives and our neighbors, I mean calling up the chairman of Procter & Gamble,
Sure.
or,
Sure.
whatever these industrial entities are. And if they hear from enough of us and we can talk to them in a way where it makes sense for them, we can create the groundswell that can lead to will, that can lead to change. That's just my personal opinion.
Hear, hear. I love it.
Thank you.
I didn't know you were here. I would have let you do that.
Thank you so much. I just wanted to say that we're so fortunate that we're here in Bloomington. There are so many ways that you can volunteer. I volunteer as a commissioner on the City of Bloomington's Commission on Sustainability, and I've created a heat management task force. It has a lot of city and county departments and nonprofits. We're all working together to create a heat management plan to work on mitigating and adapting to extreme heat. There's a lot of things that we can do. There's a lot of things in our climate action plan here in Bloomington that we're trying to implement, and we need all the help that we can get. And so I would just suggest to you to find out what your interests are. I'm sure that there's something here that can align with what your interests are. So whether it's working on, removing invasive species, working on the climate action plan, there's a lot that can be done here.
Brilliant. I think we have to let you go. Right. Yes, go ahead.
Is there anything going on within the schools?
We are working on getting some funding to map our urban heat island. And
I'm sorry.
to map our urban heat island. So we want to map our city and find out where our hot spots are. And we want to reach out to schools and get volunteers to help us to do that. So once we know where our hot spots are, we can focus on those areas and plant trees. There's some heat mitigation strategies that we can try to implement there. So I think, reaching out to more schools and getting them involved is part of what we want to do.
Perfect.
And I also want to say that, as far as, your point about trying to talk to people who have different opinions, I just completed a climate change and health course through Yale University last year.
Yes.
And we really need to start focusing on the health impacts of climate change. And so it doesn't matter if you're a Democrat or a Republican, extreme heat, it affects everyone. And so coming at it from that standpoint, I think will be very beneficial.
Brilliant. Yes. People will respond to things that affect them.
I just want to say I attended a meeting last night sponsored by the Indiana Forest Alliance.
Ooh, yes.
And you were there too. And they're talking about creating like national parks, climate preserves.
Yes.
And like we have a whole forest of hardwood here. And there are forests over in Illinois that they're much further along
Right.
in getting. And so letters to your congressmen and your legislatures and just south of here in Orange County. I don't know if you want to say any more about that.
Well,
but-
and we also have a huge project in the Hoosier National Forest in our watershed, the Houston South Project, which is currently in litigation. And then there's this new
New one in
proposal for Buffalo Springs in the Patoka
Trace or
Lake
whatever it
area.
is.
There's gonna be a big meeting, it isn't 100% sure on the time, but if you could get to Paoli, April 3rd, it's right now set for 1 to 2:30, but it's a public meeting, I believe with Wilkes, who is an undersecretary of the USDA, and Senator Braun set this up. It's gonna be a meeting with US Forest Service folks, and the public is invited, and they're hoping to get, 400, 500 people there if possible, but yeah, so this is going on right in our area. They're doing a lot more prescribed burns because they get, apparently, and I didn't know this, that they get paid every time they burn an area. So, yeah, it's not good.
Brilliant. As I predicted, the good ideas come from you. So that's brilliant. Excellent. Lovely folks.
You had some great questions and contributions from the audience. It's wonderful.
Thank you very much.
Thank you, Ben, so much.